Hi guys, welcome back once again to my YouTube channel Virtual Guru. This is Srikanth Rathod, your virtual trainer. In this video, we are going to discuss about prime and composite numbers, a very important topic as per the competitive exam concern. So, let's start with. Prime numbers are the subset of counting number. They include those non-negative integer which have two and only two factors, that is the factor 1 and themselves. In other words, we can say any number divisible by 1 and itself, or the factors of any numbers are only two factors, that is 1 and the number itself. Such numbers are called prime numbers. So if I just make a list 2, because 2 is divisible by 1 and 2 itself, divisible, it means it should give the remainder as 0. Okay, so that's we say divisible evenly. 3 is divisible by 1 and 3. 5 is divisible by 1 and 5, and so on. There are like infinity numbers. So if we make a list of the first 10 prime numbers, so this is how it goes: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. All right, look at carefully to this pattern. What you can see is 2 is the smallest and only even prime number. So make a note here. First make it 2 is the smallest and only even prime, right? Even prime. So all the numbers greater than 2, all the numbers greater than 2 all are odd numbers. Let's suppose in an exam, if a question is relating with something like x and y are prime numbers greater than 2, it means indirectly they are saying you that x and y are odd numbers, or based on the question what they're expecting to you do, so just follow the instructions and solve it. So x and y here are odd, right? Okay, now further, if you look at to this pattern clearly, what you can say is 3 is the smallest odd prime number, isn't it? If the question asks you like smallest odd prime number, that is 3, and if they also ask you the smallest second odd prime number, that is 5, right? This is the smallest second odd prime number, this is the smallest third odd prime number, and so on. We can also say the smallest two-digit prime number. Then the smallest two-digit prime number is here, isn't it? The smallest two-digit prime, and so on. Like if you look into the pattern, you'll understand whatever the question they're expecting you to know. All right, so it's just like you have to look carefully and you have to analyze. Okay, so one more thing, my question here is negative 2 a prime? This is just I'm asking you. Pause the video and see it, check it, look at the definition and all, try to answer this. Is negative 2 a prime? Let's see. Negative 2 is not a prime number. So why I'm saying it's not a prime number? As I told, negative 2 is divisible by which all the number? Negative 2 is divisible by negative 2, negative 1, 1 and 2. So this number has more than two factors, and to become a number to be prime, it has to be divisible by only two numbers, so 1 and the number itself, but it has more than 2. So that's the reason we say negative 2 is not a prime number. Then what we can conclude here then? The second point you can conclude here is only positive numbers can be prime. Numbers can be prime. All right. And what is the third point we can draw from this saying is all prime numbers except 2 and 5 are ends with 1, 3, 7 or 9. All the prime number apart from 2 and 5 ends with either 1, 3, 7 or 9. Okay, look at here. So number here is ending with 1, here it is ending with 3, the 7, 9, 3, 9. So always except 2 and 5, those number ends with this number, right? Okay, and let's see the next. Prime factorization. Every positive integer greater than 1 can be written as the product of one or more prime integers in a way which is unique. For instance, integer which three unique prime factors a, b and c can be expressed as n is equals to a to the power p times b to the power q times c to the power r, where p, q and r are the powers of a, b and c respectively and are greater than or equal to 1. Okay, so what the overall says, prime factorization is basically the splitting the number into its prime, right? Let's take an example. I have 30. What are the prime factorize or the prime factors of 30? The meaning which are the prime number which can divide 30, and those number which can divide 30 are called factors of 30, isn't it? So there are like many ways to get the prime factorization. There is one simple way what we used to follow is the factor tree method, and also other approach is keep dividing this number by the smallest prime and keep doing it till you get the end result as the prime number, right? So let me just see here with the factor tree method. 30 can be written as 2 times 15, yeah. 30 can be written as 2 times 15. 2 is the prime but 15 is not. So further you have to divide into 15 can be written as 3 times 5. 3 times 5. So I can say 30 can be written as 2 to the power 1 times 3 to the power 1 times 5 to the power 1. Why? 2 is appearing only once, 3 is also appearing once and 5 is also appearing once. So this are the prime factors of number 30. Right, this is how we have represented in this, where n is the 30. If I say a is 2, b is 3 and c is 5, and their power p, q, r and r each are of 1 here. Okay, let's take one more example. 4200, let's take it. If you go with the factor tree method or dividing by this number with the smallest prime and continued, means that's gonna take very long, is it? So the 4200 can also be written in the simplest way, like 42 times 100, isn't it? So 4200 times can be written as 42 times 100, and then write the factors of this. So what are the how the 100 has been made? 100 is basically 4 times 25, yeah. And if you are writing the factors, like 4 can be written as again 2 square, that is 2 times 2, and the 25 is 5 and 5, isn't it? So now factorize the 42 here, divide by 2, so 42 that gives you 21, and then you'll be getting the 21. What are the how the 21 has been made? It's basically 3 times 7, right? So these all are the factors of the 4200. Then how many times the 2 is appearing in this entire? One time here, here and here, meaning 2 is appearing thrice. Then what I can say here is, this can be written as further 2 to the power 3 times 3 to the power 1 times 5 to the power 2 times 7 to the power 1. 5 is appearing twice, 3 is appearing once, 7 is appearing once. So this is how do you represent the number into the prime factors. Now if there is a question asking you distinct sorry, if there is a question asking you about, sorry, if the question is asking you about, I think, wait just a second, oops. If the question is asking about distinct or different, it means distinct or the different prime factors, which we can say that is 2, 3, 5, 7. When I'm talking about the distinct or different, I won't be talking about how many times the 2 is repeating, how many times 3, how many times 5 are repeating. These are the distinct or the different prime factors of the number 4200. Okay, all right, let's move next. This is how you find the prime factorization. Verifying a prime numbers, checking whether a number is prime or not. So verifying a prime number is the concept mainly required for the competitive exams, which they don't allow you to use a calculator such as GMAT. Okay, then how do I verify whether 161 is a prime number? So for that one, what we need to do is, let's consider n to be like 161 and take the square root of n, 161, the square root of n, and whatever the result you are getting, square root of n, let's take you are getting the some result as, let's say, the 12 point something or 4 5 something. Now you have to divide n by all the prime numbers which are lesser than this. So why I'm saying the square root of 161 as 12 point something, how did I know? That is, look at how I'm just concluded. 2 square is 4, 3 square is 9, 5 square is 25, 7 square is 49, then the next prime is going to be 11 square is 121, and next prime is 13 square is 169. So whichever the number 161 they have given to us, that is greater than 121 and the smaller than 169. So definitely square root of this number should be greater than 11, sorry, it's 1, yeah, square root of this number should be greater than 11 and the lesser than 13. That's what approximately I'm taking it as the 12 point something. So this number we have to divide by all the prime numbers which are smaller than 12. That is, which are those now? 2, 3, 5, 7, 11, right? And if n is divisible, then it's not a prime. If n is divisible by all this number, then it is not a prime. If n is not divisible, then it's a prime. It's a prime. This is how you decide. Divisible or not divisible when I am talking about the dividing by these numbers. If the n is divisible by any of this number, or 161 is divisible by any of this number, then 161 is not a prime number. If it is not divisible, then it's a prime number. Now let's check whether it is divisible or not. So 161, alright. Now how do I verify whether it is 161 is divisible by these numbers or not? Look at which are the number divisible by 2. If any number ending with 0 or multiples of 2 are the number which are divisible by 2. I'll be uploading my next video which clearly explains like the divisibility rule and the shortcuts like finding the square root and all. Please refer to the next one, okay? As I'm just now referring as per the question concern. So any number which are divisible by 2 are those the number should be end with the multiples of 2, either 0, 2, 4, 6, 8 and so on. But The number here is ending with 1, so that number is not divisible by 2. 161 is not divisible by 2. So scratch it. Now let's check with the divisible by 3. The rule for the divisible by 3 is if the sum of the digits are multiple of 3, then the number is divisible by 3. If the sum is not multiple, then the number is not divisible by 3. So what does it mean? Sum of the digit, what it is? 1 plus 6 plus 1. So total sum I am getting it 8. If this result turns to be a multiple of 3, that is either 3, 6, 9, 12, 59, so on, then this number will be divisible by 3. If it is not, then it won't be divisible by 3. So as the number is not a multiple of 3, then 161 is also not divisible by 3. Similar to the divisibility of 2, if any number ending with 0 or 5, those number are divisible by 5. If not, those the numbers are not divisible by 5. So the number here ending with 1, not with the 0 or multiples of 5, so that's why 161 also is not be divisible by 5. Now check with the divisible by 7. So let's check. Of course there is a rule for the divisible by 7 and 11, so I'll be showing that in my next video in a detail. So now when I'm saying the divisible by 7 or not, let's just check with the long division. 161, just try to do the long division. How do we do the long division? First, look at to the number. You are dividing 161 by the 7. Now 7 is called the divisor. Look at to the first number. If my first number is smaller than the divisor, then you have to take the number together. You have to take the number together. I mean, like you have to take the two digits together. So you have to take 16 together instead of just taking one, right? Now then you have to read the 7 times table, like 7 times 1 7, 7 times 2 14, 7 times 3 21, 7 times 4 28, and so on. You'll be counting the 7 times table unless and until you reach exactly to the 16 or lesser than that. You should not exceed that number. Okay, so 7 times 2 gives me 14, and which is smaller than 16. I can't go with the 7 times 3 because 21 is greater than 16. You have to choose the number which is smaller than the number which you are talking about, that is 16. So then after choosing this, you have to do the minus, that's subtract. So 6 minus 4 is 2, 1 minus 1 is 0. Then this number is smaller than 7 again. So now you can take the number which is left, carry forward that. So 21. So 7 times 3 gives us 21 minus 0 0. Look at the number here, 161 is completely divided by 7. Divided meaning it giving the remainder as 0, right? So that's why we say 161 is not a prime number. As it is getting divisible by 1, stop it, don't check with the 11, because if it is getting divisible by 1, then whether it is divisible by 11 or not, it's not a prime number. It's not a prime number. This is how you check whether the number is prime or not. All right. Okay, so let's move to the next. Composite numbers. A positive number that has more than two factors. Also, any non-prime number greater than 1 are said to be a composite number. The example includes 4, 6, 8, 9, 10, etc. So in simple word I can say the number which has more than two factors are called a composite number. So if you write 4 is divisible by which all the number? 4 is divisible by 1, 2 and 4. If you are talking about 6, 6 is divisible by 1, 2, 3 and 6. If you are talking about 8, 8 is divisible by 1, 2, 4 and 8. 9 is divisible by 1, 3 and 9. So look at these all number has more than two factors. So these are called composite numbers. right? And note that 1 is not a composite number and 4 is the smallest composite number. We told you why the number 1 is not a composite, not a prime, not, in my previous video, because 1 is the unique number. It's not, so any number multiplied by 1 results in the same value, or any number divided by 1 results in the same value. That's the reason we say 1 is a unique number. So 1 is not a composite, and the 4 is the smallest prime number. All right, that's it for today's class. Thank you so much for watching. Please like and subscribe to my YouTube channel so that whenever I upload a new video, so you'll be knowing it. All right, so thank you so much.